Welcome student in our virtual classroom. The subject that I'm going to discuss is workshop, workshop and manufacturing practices, and it is the fifth lecture on the subject. The topic is machining and machine shop. Now, what is machining? If you want to shape the metals, especially metals, and sometimes machining also done in wood or other materials also, but predominantly it is the metal, is the workpiece on which will machine means remove the material to give desired shape and geometry. Remove means cut the material, and this cutting is done with the help of some machines. That is the function of this shop. Say, as per example, you want to make nut, bolts, or body parts of a machine. Means in the machine shop, machine also can be manufactured. Now, please follow this lecture. Machine shop. What is the function of a machine shop? Machining operation is performed here. It is a photo of the institute BBIMT, where a number of machines are there for the machining operations. Now, what is this machining operation? We have to remove the material. How to remove? By cutting operation. Various type of cutting operation. Then why? The reason is we want to obtain the required shape and geometry of the object. Predominantly, the metals and metallic work are done here. Metals are given with desired shape. The as per the operation, various types of cutting, a number of machines are available there. Like there's a turning machine. Generally, lathe machines are used for turning, and as well as the boring machines. Boring means where the holes are increased in size. Shaper and the planer machine. Plane surface are generated by these machines. Drilling machine. We know that a hole, cylindrical hole is made by this drilling machine. And this is the milling machine. Milling machine means we can cut the slot by this milling machine. Then it is the grinding machine. The finishing or of the job can be done, or we can sharpen the surface of the job by the grinding machine. The job here may be the cutting tool also, and other very common machine in the machine shop is power saw. The saw that is driven by motor. That's why it is called the power saw. Metal are simply cuts by this machine. So these are the common machines in the machine shop. Beyond these machines, so many machines are also available. In our workshop, these six types of machines are available at BBIMT. The various machines like this shaping machine. We know for machining, as a machine is required, these as well as a cutting tool that is also used. These are the samples of cutting tool used in the shaping machine. The cutting tool function is to cut, and this cutting tool is operated by the machine. For all the machines, there is a cutting tool based on type of operation. In some of the cases, the turning tool is also used for shaping purpose. In our lab, there are two shaping machine. This milling machine. What is done there? A slot is cut by this machine. A multi-point cutting tool is there. A number of cutting points are there. These also are called the teeth of the cutting tool. Multi-point. These. So a number of cutting tools are there, and this cutting tool is rotating circularly while the job is moving in linear direction, and then the cutting operation is performed. And this is the drilling machine. There is a this is called the twist drill or a drill bit. It is attached here. This is the tool holding device, and this is the cutting tool. This is the drilling machine, and circular holes are produced. The dimension or diameter of the hole is same as the diameter of this cutting tool, and this part is called the flute of the tool. Through here, the chip after cutting is removed through this flute. This is called the twist drill, and this is the double point cutting tool. This is the one cutting edges, and this other cutting edges. So this is the 2 point cutting tool. In the grind machine, what we are doing in especially in our workshop, if the cutting tool is blunt, means the surface, the cutting edges is damaged due to repeated operation, it can be sharp by this grinding machine. This is called the grinding wheel, where the abrasive coatings are there, and it is rotating at very high speed, and when it is in contact with the cutting tool is sharpened. So this is the function of the drilling grinding machine. Now it is the power saw. As I have told you that simply it is the saw. It cuts, but this saw is powered by this machine, by this motor. So it is called the power saw. It's definitely a types of hacksaw, which is powered by motors. So metallic pieces can be say a metallic rod. You want to make two pieces of the metallic rod, that it can be cut by this power saw. Now, as we have seen, various cutting tools are used as per the application and as per the machine. Application means the operation, what types of cutting we want to perform. These are the common tools, cutting tools that we use in the lathe machine, and this type of tool is also used in shaping machine. The cutting tool materials is something different from the common workpiece material. So what is the difference? The difference is it should have high strength, means high hardness. Say the workpiece means the job. Generally, the material, if it is the mild steel, compared to this mild steel, the cutting tool material should be hard. We know that there is a friction between the cutting tool and job. If it is not enough hard with respect to the workpiece material, then there will be a first damage of the cutting tool. That's why high carbon steels can be used as the cutting tool. It is the material property that if the carbon percentage increases in the steel, then it makes hard. Other most important property of this cutting tool material is it can withstand high temperature. Why it is required? During the cutting operation, the tools getting heated, and it is expected that at that high temperature the strength will remain, sufficient hardness will remain there. So hardness at high temperature is also another property of the cutting tool material while selecting the cutting tool material. So high carbon steel, and along with that HSS, high speed steel, which is an alloy of carbon, chromium, vanadium, and definitely iron. Major percentage is iron. So that is called the high speed steel. Why it is called high speed? The reason behind it is, as compared to this high carbon steel, high speed can be given in case of high speed stool. We know if high speed is there, then more heat will generate and the tool may soft due to that high temperature. But this high speed steel at the elevated temperature also it gives the hardness for cutting. Now the next the other materials widely used, that are cast cobalt alloy, various metallic carbides, and sometimes hard material coatings are used, ceramics, and cubic boron nitride. So these all are the materials that satisfy these cutting property of cutting tool materials. Now mainly we will discuss here the operation in lathe machine. Most common and widely used multi-purpose machine tool is lathe machine tool. Actually, with the help of this machine tool, we can perform numerous types of cutting operation. As already I have told you that for a shaping, means making a plane surface, we are using the shaping machine. To make a slot, we are using the milling machine. To make a drill hole, we are using the drilling machine. But all these operation, making a drill, making a key slot, making a plane surface, a lathe can be used with separate attachment. But the lathes are widely used not for that purpose, rather speciality of this speciality operation of this machine is to make cylindrical job. If you want to get a cylindrical surface, then mainly lathe machines are used. Otherwise, for other operation, though by the lathe that operation can be done, like say making a hole, but in that case drill machine is specialist for that purpose. I repeat, by the lathe machine that operation can be done, but lathe machine is not a specialist for that purpose. Rather, for the cylindrical job, lathe machine is a specialist. The components, various components of these machines are these: headstock, headstock assembly. Here, the chuck. This is called the chuck. Spindle. On the spindle, the chuck is mounted. Then what is chuck? It is a job holding device. Job holds by the chuck. Various types of chucks are there. Here in our machine, it is the three jaw chuck. This three jaw. This is also called the self-centered chuck. Then it is the tool post. Cutting tool is placed here, and the movement of cutting tool can be controlled by here. It is the compound rest where the cutting tools are rest. This is the cross slide. Cross slide means we can slide it in the transverse direction, and the speed of the spindle can be controlled by here. A number of gears are there, and we can achieve various types of speed by the combination of the gears. These are the two levers by which the speed is selected. Then uh, these are the three rod like things. This is called the lead screw, and then these feed, and details I will explain it. This feed mechanism. This is called the tailstock, as it is the headstock. Similarly, it is the tailstock. So, what's the function of tailstock? If the cylindrical job is with a very high length, then only the chuck are unable to hold it horizontally. That's why it is holding in between the chuck and this tailstock. At this end of this tailstock, this point is called the dead center, because this center is not rotating, unlike this center, and the cylindrical job is placed, the axis is placed along this center to this center. This is called the bed. Now in details we will see these beds and other components. The lathe bed here. This is the bed, and this carriage, this is called the carriage, which is carrying the tool, cutting tool. This is the cutting tool, and the cutting tool motion is also controlled, and the entire this carriage assembly is runs over this lathe bed. This is the magnified view of this bed. As already I have told you, say this is the chuck. The magnified view is this. These are the three jaw chuck. These three. One, two, three. These are the jaw. The special feature of this three jaw chuck is it is self-centering. Means if we control this particular job, then automatically this job will also come close to the center. And if we displace this particular jaw opposite in that direction, then simultaneously these two jaw will also move in outward direction. Means individually or independently we can't control this jaw, and that's why a workpiece is automatically getting its center, means automatic alignment. So that is the facility. But if the surface of the workpiece is not regular, cylindrical, in that case we can't use this three jaw chuck. Then some four jaw chuck and other uh, holding devices are there to hold that. The tailstock that already I have told you, this is the magnified view of the tailstock. This is the the dead center, and the entire using this lever, just we can move these dead centers. And sometime if the cylindrical job is very much big, in that case we can remove this part, and through this tailstock there will be only a hole, and this cylindrical job can pass through this, and it will be in contact with the chuck and it will pass through that. So this is the function of the tailstock. The carriage means it is carrying. What is carrying by the carriage? The entire tool post, the cross slide, the feeding the system. So that is the carriage, and the tool post is also there. Cutting tool is placed here. This is the holding device of the cutting tool. With the help of generally with the help of nuts, the uh, cutting tools are holds. And it is in this tool post multi-point cutting tools, a number of cutting tools may be placed here. And generally for cylindrical job, all the cutting tools are single point cutting tool. And using this lever we can move this carriage in the forward direction, and using these knob, by rotating this we can move in cross direction of this tool post. Just notice how we are feeding. Here the job will continuously rotate at a fixed position, and this tool has to move. And when we are rotating this disc, then it is moving like this. And when we will rotate in opposite direction, the tool will move apart from the job. And by this we are giving the cross feed. In cross direction we can move the tool post. So this is the function of this two system. And here uh, for what rotation in linear direction, how much it will give, it can move. The feed means the motion of the cutting tool placed on the tool post is controlled by a mechanism, that is the feed mechanism. The cutting tool can move in the cross direction, as I have told you and shown the video, and along as in the forward direction. and this is the feed rod by which without manual feeding automatic feed also can be given. And for automatic feed, what is the rate of feed? Rate of feed means how fast the tool is moving towards the cutting tool or along the cutting tool. For that speed is the feed rate, and that can be controlled by this mechanism. A number of gears are there, and the combination of these, by the combination of these gears, we are getting various feed speed in cross direction and in longitudinal direction. And manually it is controlled from here, and this is the automatic feed control device. A chart is given here where we can select the feed, and in case of thread cutting means in case of say nuts and bolt, internal and external threads are there, that also can be done in a lathe machine. And thread means that this is also on a cylindrical job only, and that's why this lathe machine, as I have told, it is a specialist for any types of cylindrical job. So in case of thread, quickly we can set the thread from this gearbox. There is a gearbox. Using this lever, we can get the various thread. The motions that is available here, as I have told you, the longitudinal and cross. In addition to that, angular motion in a angle manner the cutting tool is moving, that is also possible. So how angular motion, both the longitudinal combination of this longitudinal and the cross direction, that is the angular motion of this means in a particular angle. Angle means along the straight line definitely, but not longitudinal or cross, but in the in between that a certain angle it can move. And already I have told you the various types of operation that can be done in a lathe machine apart from the cylindrical job. That's are these are the list: the straight turning, the shoulder turning, and the drilling, reaming, boring, counter boring, and so many, means almost all the machining operation can be done. And for that the workpiece holding device always not three jaw chuck, rather various types of holding device are used. One of that is faceplate. For very irregular shape of the job, the faceplates are used. And as I have told you, though all these operation can be done, but these straight turning means this turning, the thread cutting, the facing, knurling means for this cylindrical operation, that is more suitable for the lathe operation. It is a very common tool, cutting tool used in lathe machine. And these are the components. These two are the cutting edges, these edges and these edges, and this is the face. This is the geometry of the cutting tool is shown, and this particular geometry is suitable for turning and facing operations. But for the operation which is not turning and facing, say it is the grooving operation, parting operation, then tool geometry is not the same. So depending on the operation, we decide the tool geometry. And some of the very common tools used here is this. And all here is single point cutting tool. At a time, only one cutting edge is in operation, and that's why it is called the single point cutting tool. In shaping machine, again these single point cutting tools are used. Now we study the cutting parameters. What is the cutting parameters? It is the motion of the cutting tool and the relative motion between the cutting tool and the workpiece. So what parameter we have to set? So before going to discuss, let's see a video of machining operation. Here the tool is moving across the length of the job. This is called the feeding, the movement of tool across the job. This is called the feeding. At what rate feed is given? So that is a cutting parameter. Otherwise, there is a relative velocity between the contact point and the job, contact point of the tool and the job. That velocity is the cutting velocity. And the third parameter is the depth of cut. Now let's see how the depth of cut is given. The cutting tool can be moved along the cross direction, that will give the depth of cut. Let's consider it is the first position and we are rotating this wheel. Small divisions are there, say 10 number of small division we have rotated, and we know one small division of this wheel means the in the cross direction the tool will move 0.02 millimeter. So 10 division means 0.2 millimeter, and that's why the depth or penetration of the tool in the job is 0.2 millimeter. Means there is a reduction of diameter is zero point 0.2 plus 0.2 equals to 0.4 millimeter, and that is the depth of cut, which is the third parameter of machining operation. Okay, as we have seen the motion, now let's discuss and find out the equations of the cutting parameters. So first is cutting speed, which is the relative velocity between cutting tool and the workpiece. And as in the lathe, for this particular operation and this cutting speed, that is the whatever formula will drive, that is not same for all the operation. This depends on the operation. See, in case of this particular operation which is called turning, initially the job was rotating at a speed of n rpm, say. Then the tangential to the cutting tool is in contact with a job at a particular point at a particular instant, and if we draw the tangent from that point to the circular job, then that is the direction of cutting speed. And what is the magnitude? For that particular instant, we can consider that the in the tangent direction there is no movement of the cutting tool, so the cutting tool can be considered as stationary and the job is rotating in circular path. So the tangential velocity is pi dn, which is called the cutting speed. For d is the diameter of the job, means the workpiece, and n is the rpm of the work, means at what speed the spindle is rotating. So this is the cutting speed. And quite naturally, if the cutting speed is high, the total machining time will be less. Means less machining time is required to perform the same operation. The next one is feed. Okay, the job was rotating. Now, if the tool is actually stationary, then there is no progress of the cutting. So, tool has to move along the length of the job. That is the feed. Let's consider to move the total length of the job, it takes t time, for L is the length. Then L by T is the rate of feet. Now, if this quantity is divided by n number of revolution, then we are getting for one revolution of the job, the tool is moving along the length what distance. Then that is the feed rate, and the unit is millimeter per revolution, and where T is the machining time. So, actually initially we will select the cutting speed, then using this equation we can calculate the machining time T, and we also can select the N, and we know the job length. The third parameter is the depth of cut. As I have shown you in the video that the diameter is reducing. Then what is the radial decrement of the diameter of the job? That is d1 minus d2 by 2, but d1 is the initial diameter, d2 is the final diameter, divided by 2. That is the radial decrement, or this is the depth of penetration of the cutting tool into the job. That is the depth of cut. And quite naturally, if depth of cut is high, then fast all these parameter, if it is cutting speed, feed, depth of cut, all is high, then machining will perform fast. But if we give all these parameter high, then the tool may damage very fast, and if these parameters is very small, then the machining time will require more and more. And that's why we have to find out an optimum value of all these parameter, speed, feed and depth of cut, so that there is no damage of the cutting tool. At the same time, the machining time is also satisfactory. So this is all about these cutting parameters for turning operation. The references that I have used to prepare this video lecture is given here. So this is the brief of the introduction of the machine shop. Now in the next lecture I will discuss the one of the machining operation, that is machining on lathe. I'll request you to follow the subsequent lecture also, and thank you for your patience. And I would like to request you, if you have any doubt or you think that some modification is required, please make a comment so that I can improve my lecture. Thank you.